Good morning, students. Today, it's the good morning, students. Once again, today it's the first class. Today it's the first class. So today, I'm going to here the subject what I'm handling is CPS. CPS stands for C programming for problem solving. Okay, Dr. Ranganatha S. Assistant Professor, Department of Computer Science and Engineering, Government Engineering College, Hassan. Today, I'll teach you about the basics of computer and computer generations. So, have shared the PPT. Along with this, you'll also get some notes and multiple choice questions. Please make use of it. So all of us know a computer is an electronic device that can automatically perform a set of instructions. Okay, it's an electronic machine capable of performing a set of instructions. So a computer takes as input the instructions as a single unit, uses them to manipulate data, and outputs the results in user specified ways. The processing is very fast, accurate, and consistent, and is generally achieved without significant human intervention. It's not that we can do our work without computer. Uh, Human being is capable of performing all the calculations, but why we are behind computers? It's because of their speed. The main reason why we are behind computers, it's because of their speed. Okay, two important words in the world of computer science are time and space. Okay, space means memory, and probably because of the technological improvements. Okay, today memory has become cheaper and cheaper, uh, but still we are very much interested in memory as well. But however, time is time. Once it's gone, it will never come back. So why we are still behind computers? It's because of their speed. Because of their speed, they are capable of doing many tasks at a time. Okay. So a computer has an important unit called by the name CPU. CPU stands for Central Processing Unit. Hope all of you have seen the big box whose primary task is to process the instructions. An instruction can do only simple work like moving a constant to a register. The CPU includes important elements like ALU and control unit. ALU stands for arithmetic logic unit. Arithmetic and logic unit is used for performing all the arithmetic and logical calculations. Control unit generates the control signals from time to time. And apart from control unit and logic unit, control unit and ALU, CPU also includes instruction register, program counter, memory address register, and memory data register. Instruction register holds the instruction to be executed. Okay, computer executes one instruction after the another. Okay, an instruction, the program is first of all central processing unit. It executes the programs written by the users. A program is a set of instructions. Okay, instructions are executed within the CPU. And within the CPU, there are parts like arithmetic logic unit, control unit, instruction register, PC, memory address register, memory data register, etc. Instruction register holds the instruction to be executed. PC is another important register which contains the address of the next instruction to be executed. Okay, because CPU executes instructions one after another. So PC is a register, okay, which is part of CPU, which holds the address of the next instruction to be executed. Registers are nothing but memory spaces. Okay, so they have little space. They are very few in number. We cannot keep the whole program within registers because each is capable of holding only a small amount of information or data. Okay, they're used for holding the data temporarily. So bigger than registers is memory. Within the CPU, we will find cache memory, and outside the CPU, we will find memory. If I am talking about memory, if I'm talking about the word memory alone, it means I'm talking about primary memory, RAM, random access memory. Okay. Before RAM, cache memory comes, and registers are part of CPU. Okay. So there are two levels of cache memories, level 1 cache and level 2 cache. Level 1 cache, sometimes it's part of CPU. Level 2 cache can be inserted outside the CPU. In today's computers, we'll find 2 or 3 levels of cache memories, and it depends on the manufacturer. So bigger than cache memory is the main memory, and if we cannot keep all our programs and data when the instructions are getting executed. Okay, so permanent storage is secondary storage, like our hard disk. So programs need to be loaded into primary memory. Okay, when if you want your program to be executed and considered for execution by the CPU. So these steps, whatever I'm talking, are going to be explained again, because we will come across the central processing unit, primary memory, and secondary memory again. But for now, a computer is an electronic device that performs a set of instructions. The computer takes the instructions as input, uses them to manipulate the data and outputs the results in a user-friendly ways. Processing is very fast. Computer includes CPU, okay, and that is capable of doing calculations faster than us, definitely. Okay, so instructions need data to operate on, and this data can be made available from multiple sources. I mean, you can provide. So simply saying, computer is a machine to which we need to provide the input, and you can expect the output. Input can be provided from multiple sources like keyboard. For instance, input can also be provided through other files or from other sources that you learn slowly. But for now, you can provide the input from keyboard, and output definitely it's going to be seen through your monitor, the main output device. Data may also occur in the program itself. It's not that always we need to provide the data through the keyboard only. Data may also occur in the program itself. The output could be written to any device, a disk, a monitor, or printer. As I said, normally you'll able to see the output on the monitor, or it can also be sent to the disk, printer, because they're also the output can be sent to the disk for permanent storage, or if you want your uh, if you want to print the output being generated, then it can be sent to a printer. You can do many more things. So abstractly speaking, computer is a device that can perform a set of instructions. Central processing unit, it's very important for us because it is capable of executing instructions, and we need to provide the input to the CPU and output comes out. So just for time being, you can think like CPU as a black box. Okay, because this is the first class for you. You doesn't know what how CPU works. So let's keep it as a black box. Black box means when you do not know what's happening inside and what is contained, then it looks like a black box. You just know how to provide the input to it and what's the output coming out from it. So it's a machine. It's an electronic machine which takes input. Okay, which takes input and output is generated. Let us talk about the computer generations. Okay, as I mentioned in today's class, I will talk about computer basics, about computer, what's a computer, and let's also talk about computer generations. We have seen many computer generations. Okay, so computer of each generation is faster. Okay, as the generations passed on, the size became smaller, and as far as power is concerned, computers started becoming more powerful than its counterpart of the preceding generation. So consequently, advances in hardware have also resulted in the development of powerful and user-friendly programming languages. Okay, so you can able to see the table 1.1 showing different computer generations that are based on different technologies. I will talk about each generation in detail, okay, in the upcoming slides. So let us talk about the first generation computers. Okay, first generation computers used thousands of vacuum tubes for computation. Definitely, the computers of that generation were bigger. Memory requirements were met by magnetic drums, forerunner of today's hard disk. Magnetic drums. Because of the size of vacuum tubes, first generation computers took up a lot of space. Okay, you can able to see in the diagram on the top right corner of the slide. Okay, the systems, the computers of that generation were bigger. They also consumed enormous amounts of power and generated a lot of heat. Machines of this generation were prohibitively expensive to buy and maintain. First generation computers were programmed using a first generation language called by the name machine language. The machines of that generation used the language called by the name machine language. Okay, machine language used only zeros and ones. Machines still today they are capable of understanding only zeros and ones. First generation computers directly used language called by the name machine language. The reason why these computers were difficult to program, it's because they were capable of understanding only zeros and ones. Machines of that generations were capable of understanding program returns using only zeros and ones. That's why during those days it was very difficult to program because users need to write programs using only zeros and ones. That's why it was very difficult to write the program. Program input was provided by punched cards and output was obtained on the paper. Okay, as I told in the previous slide, like for today's computers, you can provide the input through keyboards or through files or through some other mean, but for the computers of first generation, okay, users used to provide the input using punch cards and output was obtained on the paper. Because of the mentioned drawbacks, first generation computers were only used for scientific work and not deployed commercially. Okay, so first generation computers were not used by the laymen or the outside public for teaching or for business purpose. They were used only for scientific work and were not used or provided to the outside customers because it was very difficult to program and they were very big in size and the cost was definitely was not affordable for the general public. And that's why first generation computers were used for scientific work. Let us talk about the second generation computers. Okay, first generation computers used vacuum tubes. Second generation computers replaced vacuum tubes with transistors, which became available during 1950s. Second generation computers, so there was roughly 1950s. Compared to vacuum tubes, transistors were definitely faster, smaller, and consumed less power. Okay, vacuum tubes, compared to vacuum tubes, transistors were faster and definitely smaller. And as far as the power consumption is concerned, transistors consumed very less power. Small magnetic cores also replaced the first generation drums. Okay, the size, because of these factors, the size reduced. Even though transistors generated less heat, second generation computers still needed air conditioning. Okay, though the amount of heat generated was less compared with first generation computers. Still, second generation computers needed air conditioning. Second generation computers were programmed using a symbolic or assembly language. As we have seen in the first generation computers, as I quoted, first generation computers were programmed using machine language. The language used during first generation computers was the machine language. Okay, users used to write the programs using only zeros and ones, but here in second generation computers, programs were written using assembly language. In case of assembly language, we use words like add, capital letters, add, add, sub, sub, div for division, mul for multiply. So words of that kind are called by the name mnemonics, mnemonics, mnemonics. Okay, they are symbolic, rather digits like zeros and ones. Second generation computers used mnemonics. Programming was no longer a nightmare because a programmer could satisfy words and symbols as instructions instead of zeros and ones. It's somewhat easy to write programs using assembly language because users were able to use the mnemonics like add, add, mul for multiplication, sub for subtraction, div for division instead of using zeros and ones. It's very difficult to understand or remember the instructions that were using zeros and ones. And so instead of that, users use mnemonics, assembly language programming during second generation computers. That's why it was somewhat easy for them to write programs during second generation using assembly language. The computers also implemented the stored program concept. Stored program concept. I mean, you can able to store your program, okay, before it's being getting executed, which allowed both program and data to reside in memory. Okay, so you can able to load because we need to load a program and data into memory before your program is considered for execution by the CPU. So it's called stored program concept. Second generation computers were implemented using stored program concept. Higher level languages like COBOL and Fortran also began to make their appearance. Okay, higher level programming languages like COBOL, Common Business Oriented Language, and Fortran stands for Formula Translation. Programming languages like COBOL, okay, and Fortran also began to make their appearance. These languages were soon to displace assembly language for most applications. Since languages like COBOL and Fortran were started appearing during second generation, they started replacing both the machine language and assembly language. Let us talk about third generation computers. This generation bid goodbye to punched cards and adapted keyboard and monitor to interact with the user. Okay, so keyboard is used for providing the input and monitor to interact and getting back the output. As you can able to see, the computer on the top right corner of the slide. Okay, so users can able to provide the input through the keyboard and monitor to interact with the user. Memory capacity was increased substantially and the magnetic hard disk was used for secondary storage. Okay, so third generation computers also had an operating system, which is a special program meant to control the resources of the computer, like operating system. It's an interface between the user and the hardware. Probably you have seen the Windows operating system. Linux is an operating system. Okay, it's a system software which is in between the user and the hardware of the system. With the assistance of the operating system, you can able to interact with the hardware. Okay, so Windows, it's having graphical user interface. Earlier we had MS-DOS, which was called by the name character user interface, because users used to write the commands for getting their work done. At Windows, it's based on graphical user interface concept. You can able to see colors, you can click on the folders. Okay, you can drag and drop, you can do with assistance of mouse. Okay, so there are different operating systems. Linux, within Linux again there are the different versions or flavors like Red Hat, SUSE. Okay, uh, third generation computers had an opportunity to use the operating systems. It's a special program. You can think of it as a manager of resources. Okay, it's a manager of resources like our governments. Okay, government will make use of the resources, and governments just manage the resources, just like governments operating system. It's a manager of resources. By virtue of a feature known as time sharing, computer could run programs invoked by multiple users. Time sharing, computer time is shared across multiple users. Okay, it was the concept introduced during the third generation. Existing programming languages were supplemented by Basic, C, C++, and Java. Basic is it's a programming language. It stands for beginners all-purpose symbolic instruction code. Basic. And C, C++, C, of course, you have in your syllabus. C for problem solving. Okay, it's an important programming language, high-level programming language. And C++, uh, C++ is equal to C plus classes. Okay, roughly speaking, C++ is equal to C programming language plus classes. Probably you'll learn about C++ and other C++. It's called object-oriented programming language. But you can learn it, or you can also learn probably you're going to learn other object-oriented programming languages like Java or other. Okay, so apart from the existing programming languages, like as we have seen from the first generation computers used machine language, then assembly language came into picture. Assembly language used mnemonics, machine language used zeros and ones, then assembly language used mnemonics, and then programming languages like COBOL and Fortran started appearing. Then apart from the existing programming languages, other programming languages like Basic, C, and C++ started appearing during the third generation. Okay, then programming became much easier. Users no longer, uh, mm, were able to remember zeros and ones for what they had like have to do during their program writing for first generation computers. Now it's easy because high level programming languages uses English like statements, okay, for writing programs. Let us talk about the fourth generation computers. In this current generation, which produced the microprocessor, integration of components went several steps ahead. Okay, so fourth generation computers. In case of fourth generation computers, an important element introduced was called by the name microprocessor. Okay, so integration, I mean incorporation of many elements. It went several steps ahead using LSI. LSI stands for large scale integration. VLSI stands for Very Large Scale Integration. They are the technologies. Using LSI and VLSI, it's now possible to have the entire CPU and its associated memory and input-output control circuitry on a single chip. Okay, you can able to accommodate. CPU, memory, and all the input-output circuit on the single chip. Okay, so definitely because of this, the size will going to be reduced. Okay, in the beginning itself, I quoted as the generations passed on, the sizes became smaller, processing power started increasing. Okay, caste wise, caste started becoming lesser and lesser. Uh, Microprocessors have invaded our homes to drive desktops, laptops, smartphones, microwave ovens, and washing machines. Today, microprocessors were used in different devices, not only in computers. CPU microprocessors are also used in laptops, smartphones, microwave ovens that are used for cooking purpose, washing machine, small chips for control purpose, on and off, and for showing different signals, whether the machines are working properly or not, or if there are any grievances, or if there are any problems, then they will show different colored lights. And for these purposes, microprocess, and for temperature variations, or for keeping the temperature for cooking purpose, and keeping different types of temperatures. So you can control the machines. You can control the machines using the microprocessors, and they are used in different types of machines, not only in computers. Fourth generation languages, okay, which resemble natural languages, have also come into being. This generation has also made rapid strides in networking technology. Okay, uh, sharing of information became possible by connecting computers in a network. Look at how technology started coming into picture as the generations passed on. Sharing of information became possible by connecting computers in a network using TCP/IP technology uh, developed by US Department of Defense. Millions of computers are today connected to this vast network called internet. Okay, the word what I used first was network, then I used internet. What is internet? It's a network of networks. Okay, so uh, it's a technology. TCP/IP we will call it as a protocol. We'll learn about it slowly. Using that, we have then we could able to connect millions of computers mm, connected to the vast network called by the name internet. So networking, internet, and different integration technologies like LSI, VLSI. Okay, these were the advancements in the fourth generation computers. Then let's continue with the fifth generation. Fifth generation represents a vision of the computers of the future. AI. Today we know what is the importance of artificial intelligence. AI. Artificial intelligence and use of natural languages are the main features of the generation. Natural languages. Okay. Fifth generation systems should be capable of producing human-like behavior. Mean we expect our machines and different devices to, like our cell phones or smartphones, to detect and recognize human behavior. These systems are expected to interact with the users in natural language and learn from experience. We expect our machines to talk to us using the languages what we speak, and we expect them to learn from experience. It's about artificial intelligence. Speech recognition, speech output should also be possible with these systems. As complexity increases manifold, the following things need to happen. Computer speeds need to make an exponential jump, a feat that would be possible using quantum computers. If a machine has to learn itself, quantum computing will help it to solve a problem in an instant. Computers must be able to perform parallel processing so that multiple processors can concurrently handle different aspects of a problem. I mean, parallel processing means we expect our machines to do processing, multiple programs uh, must be executed in parallel. Okay, we expect our machines to do more work in less amount of time concurrently. Okay. Uh, then neural networks and expert systems have to be developed. These applications would be able to make decisions and advise humans by analyzing data using human-like intelligence, but without using the services of an expert. Today, we call the areas or the research areas or the machines are based on multidisciplinary aspects. Look at the word neural network. Neural probably is the word what you have learned in biology. Okay, network. It's a computer word. Neural network. It's a general word. It's used in electrical, electronics, computer, etc. Neural networks, neurons. We know how neurons will get connected whenever we learn new things. Okay, neural network and expert systems. Expert systems, they are capable of taking decisions without the help of an actual human expert. So these applications have the capability of deciding or taking decisions for human help. Financial institutions currently use these technologies for detection of credit card fraud. Okay, you can able to use these technologies for the detection of credit card frauds. I mean, or detecting and recognition of criminals or for such things. This generation is prospective and not retrospective. It is difficult to for them where this generation would end and the next one would begin. I mean, this is what is going on. Artificial intelligence and neural networks, expert systems, decision making systems. Research is going on still, and we don't know where we'll end up with and what will come next. It's very difficult to predict the future technology. Though we talk about many things, today technology is changing very rapidly, very faster. So we do not know where we'll end up with. Okay, so let us talk about the different generations what we have discussed. Look at all the generations have been written in the same table. Okay, first generation, second generation, third generation, fourth generation, and fifth generation. Duration, components, size, storage, programming languages, and the famous computers of each generation. It's been written. Please go through this slide. It's very, very important. Look at the first generation computers. The era was roughly 1940 to 1956. Okay. First generation computers, as I have already discussed, used vacuum tubes. The size of the computers of that generation was very huge. Storage devices. It was a magnetic tape, programming language. What was the programming language? It's the machine language that was used during first generation. Famous computers of that era was ENIAC, UNIVAC, IBM's 705, etc. Second generation computers, the generation was roughly 1956 to 1964. Intel Corporation. Integral component was a transistor. Okay, because transistors replaced vacuum tubes of first generation. Second generation computers were smaller than first generation computers. Storage devices. It was magnetic tape again. Programming language. It was assembly language. Assembly language replaced machine language. Assembly language was written using mnemonics, symbolic names. Famous computers of that generation were IBM 400, IBM 1600, UNIVAC 3, etc. Let us talk about the third generation. The era was roughly 1964 to 1971. Internal component was integrated circuits. Size of the computer, it was much smaller than previous generations. Storage device was magnetic tape. Programming language used high-level language such as BASIC, Pascal, etc. Famous computers of that era was IBM 360, IBM 370, UNIVAC 9000, etc. Fourth generation, the duration was roughly 1971 to 1981. Internal component was microprocessor. Size of the computer was microcomputer. Storage device was hard disk and floppy disk. Programming languages, very high level languages like C, C++, etc. Famous computers of that generation were IBM 3033, IBM System 36, Cray 1, etc. Fifth generation, duration was 1981 to present. Internal component was artificial intelligence. Size of the computer, it's tiny because look at the size of the smart phones or the tabs or laptops of today's. The size it's very minimum. Okay, laptop, palm top, personal digital assistants, palm top. You can keep on your palm. Okay, they are also called by the name personal digital assistants. Storage devices, hard disk, floppy, and optical storage. Programming languages like fifth generation machines used natural language like SQL, Prolog, etc. Famous computers of that generation are Pentium series, laptop, Palm Top, as I quoted, Palm Top, PDA is an important one for Palm Top, etc. Okay, so in today's class, have discussed what is what is a computer. Okay, and generations of computers. Computer is an electronic device and what it can do, what are the components, and different generations from roughly 1940s to the present era. Okay, so please make use of this material, and along with they'll also get some notes and multiple choice questions. Please answer the questions yourself. Though answers were also provided at the bottom, please answer the questions yourself. If you still have any doubts, you can ask to me anytime. Okay, so thank you for listening to me. I will continue with the next topic in the next lecture hour. Thank you. Thank you for listening to me. We will end our meeting. I'll continue again. Thank you. Thank you for listening.